have two sides, right? So the sheets have only one side, right? And then this has two sides. So we see that in sheet you have in the right hand side, left hand side, the electric field is how much? What is the electric field of the sheet? We have a sheet, right? So what is the electric field of the sheet in both the sides? Let's say in this side. What is the electric field? So where is your revision? This is a NCRT problem, right? Sigma by 2 epsilon naught, right?
Yes, sir.
Yeah, so this has been also taught in second chapter as well. When you were doing that capacitor, parallel plate capacitor, so you require this, right? Okay, so this is about the sheet, right? And if we have a negative one, then the electric field would be what? Outgoing or incoming? If this is negative, then electric field would be outgoing or incoming?
Incoming.
Incoming, right? Same as the negative charge. But the value would be same. Where sigma is surface charge density, right? So these are the things preliminaries that we require. And now we have to understand the charge distribution. Charge distribution in conducting plate. Right. So let's say we have this plate. This has Q charge, right? And let's assume that on this side we have X charge, right? We have X charge. Let's say this is X in this side. So what would be the charge in this side? What would be the charge in this side? Yeah. And we have to also remember that inside the conducting plate, electric field is zero, right? So can you tell me that what would be the charge on this side? Let's say I have 6 apples, right? I give 2 apples to you. Then how much do I have? How much do I have? Yes.
What, sir?
Yeah. So let's say I have 6 apples. I give 2 apples to you. Then how much do I have?
4.
4 apples, right? So similarly, total charge is plus Q, right? In this side, I give X charge. So in this side, due to conservation of charge, how much charge would be there in this side?
Zero? Or like same charge?
Same charge. In the context of this total charge and this X charge. So 6 apples, 2 apples given. Then 4 apples in this side, right? Right?
Yes, sir.
So Q is the total charge. Let's say this is X. And let's say that in this side you have Y. Right? So this Y would be Q minus X. Is it clear? Clear?
Yes, sir.
So this side would be, let's say Q minus X is positive. So this side would be Q minus X. Is this part clear?
Yes, sir.
Now, what do I know? That inside the plate, the electric field is zero, right? So due to this plate, the electric field would be in left direction or right direction. Let me write different colors. Let's say this is X and this is. Now you tell me that due to this green one, at this point, this is inside, right? So at this point, what would be the direction of the electric field? Towards right or towards left? Yes, where are you? Rishita, can you hear me? Do you hear me?
Yes, sir.
Hello?
I can hear you.
Yeah, so I'm asking that I have this positive plate. Due to this positive plate, what would be the charge, what would be the electric field direction at this point? Right,
Oh,
left.
right.
Right would be attractive. This is positive. So that would be outgoing, right?
Yes, yes, sir.
And due to this one, that would be left. Right? Clear?
Yes,
Yes.
sir.
Now you see that, if I write, because inside the electric field has to be zero. So due to equilibrium or E inside zero, then this Ex would be equal to X. Is it clear to you?
Yes, sir.
Okay, then what would be the case? So then Ex is how much? That is, what would be Ex? Ex
EX would be
sigma X by epsilon 2 epsilon, right?
yes, yes, sir.
And this would be sigma of Q minus X by 2 epsilon. Clear? So 2 epsilon naught, 2 epsilon naught cancels out. Sigma is Q by A, right? So this is X by A. This is how much? This is Q minus X by A, right? So AA cancels out and you have X equals to Q minus X. This X goes on the other side. So this becomes 2X equals to Q. So X is Q by 2, right? So the final distribution would be final distribution be what? So this would be, you have this plate, right? And this is Q by 2. And this side is also Q by 2. So this is the final distribution. Is it clear to you?
Yes, sir.
Okay, so now please note it down. Just remember that this is the case, that E inside has to be zero. Okay, and we'll talk about several cases. So let's, yeah, you just note it down from here. So you have one conducting plate, right? You have one plate. And then we'll talk about two plates. Just note it down and then we'll talk about the other things. So whenever you have noted, please tell. Yeah, whenever you have noted, please tell.
Done, sir.
Yeah. Okay, so now let us talk about two conducting plates, right? So just now we talked about one plate. Now you have what is the question? That what is the final charge distribution for the case below? Right, so you have, what do you have? You have charges Q1 and then Q. Right, both are cost. So then what is the final distribution? Can you take a guess? What would be the answer? Yeah. So let's do this problem and then we'll understand. Right. So let's do the solution from here on. Let's suppose that I take the charge at this point as x. Right. So what would be the charge at this side? Charge at this.
Positive.
No, I'm not talking about positive or negative. What would be the charge in this side?
Negative x.
Total is Q1. We have just talked about this. Q1 minus x. Right.
Yes, sir.
So now this one as a whole, we have a contribution, this contribution and this contribution. So let's take this point inside. So how many contribution would be there in this point? All these are, let's say, positive, right?
Yes,
So
sir.
one would be Ex in this side, right? And then you have EQ minus X. I'm talking about this point only, right? So let me write it here. So the other one is E Q1 minus X, right? And then the last one is this one. So due to this one, the electric field would be right or left. What would be the direction? Direction. Yeah. What would be the direction?
It would be to the left.
Left. Absolutely correct. So this would be left. So this is due to Q. Right. Give me one more. Yes. So this is, and now we know that we know E left would be E net is 0. So E left is equal to E right. Right.
Yes, sir.
So what do we have? So first one is E left is EX plus EQ2. And then E right is simply EQ1 minus X. So this is, now what would be EX? What X?
Ex would be EQ1 minus x by EQ minus EQ2.
So just the value of this EX. What would be EX? What would be Q2? What would be Q1 minus X? So this would be sigma X by 2 epsilon, right? This would be sigma Q2 by epsilon naught. This would be sigma Q1 minus X by epsilon, right? So sigma X by 2 epsilon naught. And then plus sigma Q2 by 2 epsilon naught. And then sigma Q1 minus X by 2 epsilon. All these one cancels out. And then what do we have? So this is sigma X is X by A. Q2 is Q2 by A. And Q1 minus X by A. Correct. So A, all these cancels out. And we have x goes over there. So 2x equals to Q1 minus Q. So x is Q1 minus Q2 divided by 2. Is this part clear to you?
Yes, sir.
So in here, what do we have? In here, we have this x is equal to Q1 minus Q2 divided by 2. This is the charge distribution. And in here, what is the charge distribution? The charge distribution is Q1 minus x is Q1 by 2 minus Q2 by 2, right? So this is in bracket. So this will become Q1 minus Q1 by 2 plus Q2 by 2. So this is Q1 by 2 plus Q2 by 2. So in this side, we have Q1 plus Q2 by 2. Is it clear?
Yes, sir.
Now because these are the inside of the plate, so these are two parallel conducting plates. So inside the parallel plate conducting plates, the electric field has to be zero. So whatever the charge is here, in this side, that charge has to be negative. So this would be minus x, right? Which means that this is minus of Q1 minus Q2 by 2. Is it clear to you?
Yes, sir.
Now, what you have done is that now if we use the charge conservation, so Q2 would be minus of Q1 minus Q2 divided by 2 plus of let's say 1, right? So this y would be Q2 plus this Q1 minus Q2 by 2. So how much is this thing? This is Q2 and plus Q1 by 2 minus Q2 by 2. So this is again Q1 by 2 and this is plus Q2 by 2. So again, this is Q1 plus Q2 by 2. Right, this is the answer. Oh, so this, yeah, so this goes over there and yeah. So both the sides we have same chart. Is it clear to you?
Yes, sir.
So the final distribution would be what? So the final charge distribution. This would be how much? So you have this is Q1 plus Q2 by 2. This is Q1 minus Q2 by 2. And then you have this side is minus of Q1 minus Q2 by 2. And then this side is how much? This is Q1 plus Q2 by 2. Right. Because this was what? So this was Q2 and this was minus X plus Y. So this Y was Q2 and plus X. So this was, and then we solved this thing and we got this thing, right? So yeah, Q1 by 2 and then minus of Q2 by 2. So again, this. Okay, so this is the final charge distribution. Is it clear to you?
Yes, sir.
Then please note it down. So please note it down and then we will do three plates system, right? So please note it down. Whenever you want me to scroll down, please let me. So this part, only this part is important. If we understand this part, then we can solve this question, right? So this part is Yeah, whenever you want me to scroll down, please do. Yeah, whenever you want me to scroll down, please do.
So can you go to the next?
Yeah, this one. Is it all right?
Yes, sir.
Yeah, whenever you have noted, please do.
Done, sir.
Okay, so yeah, then let's say that instead of two plates, or before we do that, let us do some questions, right? So let us do some questions, and then this will be more. So let's say that the charge one is this one, right? And then this one is, let's say, minus 4, right? So these are the charge distribution that we. Now we can directly solve this one, because this one x would be how much? This is q1 minus q2 by 2, right? So q1 is q minus of minus 4q divided by 2. So this is q plus 4q by 2, which is 5q by 2, right? So this is simply plus 5q by 2. And this one would be, the other side would be q1 plus q2 by 2. So how much is this one? This is q minus 4q divided by 2, which is minus 3q by 2. So this would be minus 3q by 2. And then this is minus 5q by 2, right? So if this is minus 5q by 2, so this side would be how much? Minus 4q equals to minus 5q by 2 plus, let's say some charge which is y. So this y would be minus 4q by 4q, and then plus 5q by 2. So how much is this? So this is 4 2s are 8 minus, and then plus 5q by 2. So this is again minus 3q by 2, which we already did. So this is minus 3q by 2, right? So this is the direct solution, right? Is it clear to you? So the final distribution would be final distribution would be what? This would be, this is plus 5q by 2, this is minus 3q by 2, and then this one is minus 5q by 2, and then minus 3q. So this is the final distribution, right? Please note it down, and then we will see that how we can, without using this formula, if we don't remember, then how we can solve this, right? So that we will also do. But before we do that, please note it down.
Yes, sir.
Yeah, whenever you have noted, please take me. Yes, whenever you have noted, please tell.
Yes, sir.
Done. Okay, so let's say that now you understood that what would be the distribution of the charges for two plates. Is it clear to you?
Yes, sir.
Now let's say that we have three. Let's say that we have how many people are there? Yeah, let's say that we have three plates, right? So let's say that we have three plates. So distribution of charges, three plates, right? So what do we have? That let's say we have one plate. This is Q charge. The other plate, this is 4Q, and then the other one which is 3, right? So for this one, what would be the charge? So yeah, so please try this one and tell me what is the answer that you get. Yeah, please try this. Okay, and how much time do I have? So you have 5 minutes. Please try this one, and if you are stuck, then I will help. So please try this question. Did you understand this question?
Yes, sir.
Yeah, so you have three plates. One has charge Q, then 4Q, and then 3Q. All are positive. So what would be the final distribution? Please try that. Okay, I have to update it in the events. Just update this one. Yeah. So what is the idea? What is the first thing that we should do? What is the idea of these kind of?
Like we have to add all of them, like the charges of each.
Where did we add these charges? We have not added any charges, right? In any of such cases, we have not added. The goal was to calculate the electric field inside. So this is the key point, right? That inside the conducting plate, electric field is 0. That is the key point. And then we wrote, let's say that this is X. So this would be Q minus X. That is the only thing that we did. And then we wrote the electric field at this point. So this would be in this direction Ex. Oh, what did I do in the previous case? In the previous case, yeah, so this was X. Yeah, so this would be Ex. This would be EQ minus X. And because this is positive, so this would be E4Q. And again, this is positive, so this would be E3Q. Right? And then E net is 0, so E left is equal to E right. So then what we will have? So we will have E X plus E3Q plus E4Q. That would be equal to EQ minus X. So this EX is how much? What is EX? Can you tell me now? What is this EX? We have done so many questions.
X equals to EQ minus X
See,
minus 3Q.
why the value of X, not from this equation, the value. This is a
EQ?
plate, right? What was the electric field of the plate? That was okay. So people are joining, right? Yeah. So think about this question, and we'll talk about this question in the next class, right? So electric